Okay, so let's begin with the warm-up for 4.7. So yesterday in class we talked about the context of having a Ferris wheel, what your radius value, your center off of the ground, and then what your time it takes to go around the wheel helps you figure out. So anytime we see the radius of the wheel given, that's your A value, your amplitude. Your D value is how high the center is off the ground. And then your counterclockwise every 18 seconds would be the period of the graph. So the problem says to write an equation for the height off the ground at any time. If you start at position A, which is the right side of the circle, so these are the easy ones, and we would write this first by figuring out our B value. If you want to stay in degrees, we'd go 360 over that 18, which would give us a B value of 20. If you want to stay with radians, you'd go 2 pi over 18, which would reduce to pi over 9. So you have two different ways you could write the equation. If you write it in degrees, you'd have an equation that says y equals 40 sine of 20 times x, and then a plus 50 on the end. If you want to stick with radians, you'd have the exact same equation, except you'd have sine of pi over 9 times x plus 50. Remember what we said yesterday in class, if you want, you can also use h and t rather than using x and y. That is totally fine and acceptable to do. So part 2 says, at what times is the rider 70 feet off of the ground? And it says to show details. So we can actually figure this out in a couple of different ways. So one of the ways is to use the degree equation. One of the ways is to use the radian equation. Mathematically, it's probably easier to use the degree equation, so that's the one I'm going to use. So we're going to set the equation equal to 70. And then we're going to solve from there. So the first thing we need to do is take the 50 to the other side. Then we are going to divide both sides by 40. So what we're figuring out is when sine 20x is equal to a half. So we first start by figuring out when is sine equal to a half. Sine is equal to 1/2 in quadrants 1 and 2. Those places are at 30 degrees and 150 degrees. The deal with those values is that's not x, that's 20x. So if I want to figure out what my values are, I have to divide both of these by 20. And that's going to give me my 2 times. So the 30 divided by 20 gives me 1.5 seconds, and the 150 divided by 20 is going to give me 7.5 seconds. If you did this in radians, you'd do the exact same thing, except at this place, you would have had your angle answers in radians, and then you would have had a pi over 9 here, so you would have had to divide both sides by pi over 9. But in context, it's the same thing. So part 3, or number 3, wants you to figure out an equation to represent when you would be at that height at any time. So what we're going to do is we are going to take and add on an n number of periods. So our period length was 18 seconds. So for one of them, we're going to take the 1.5 and we're going to add on 18n. For the other, we're going to take 7.5 and add on 18n. And this would both be in seconds. So if I want to figure out when I'm at that height, this first answer, add 18 seconds on, you can do that a number of different times, and it will help you figure out when we would be there on any time around the circle. Now, number 4, we get a little bit more complicated here. So we want to figure out when we're going to be at a height of 80 instead of 70. So we're going to do the same thing where we set it equal to 80, but the answers are going to be a little bit messier this time. So the deal here, I would first subtract 50, and then also divide by 40. So what we're looking at is 3/4 equals sine of 20x. Now the problem with this one is it's not as easy to figure out what the angle values are for sine at those places because they're not angles or sides from a special right triangle. So what we actually have to do is use the calculator to figure it out. So we're going to make sure, since we're in degrees here with our 20, we're going to make sure that our calculator is in degree mode, and mine is. So we're going to take the 3/4 and we're actually going to do the sine inverse of it because I'm trying to figure out the angle. So I get an angle of 48.6 degrees. The issue with that is that's not the only answer. Not only is there an answer from quadrant 1 of the circle, there's an answer from quadrant 2 also. So we have to understand the relationship of reference angles for sine. If I want the angle on this side, I have to take this 48.6 and I have to subtract it from 180 because it acts as the reference angle in quadrant 2. And that means that sine is equal to 3/4 also at 131.4 degrees. So those are my two answers. If this was just an x, now I have to take each one of those and I've got to divide them both by 20. So I've got 20x is equal to 48.6 and I've got 20x is equal to 131.4. If I divide those both by 20 like I did in the last problem up here, we're going to figure out exactly the times in which we'll be at that height of 80 feet. So one of them happens at 2.43 seconds. And the other one happens at a time of 6.6 seconds. So that is the end of the warm-up. I know that some of you have a second page to the warm-up. You can ignore the second page. This first page is really all I wanted you to focus on so that you're prepared for any questions that you might see on your quiz.